Good afternoon, everyone. I'm Hao Huang, Assistant Professor of Social Sciences, and welcome to Illinois Tech Social Sciences Great Problems, Great Minds Seminar Series. For this seminar series, you can submit the questions during the webinar by typing in the chat box. We will open the floor to questions at the end of the webinar. Today's speaker is Dr. Lin Liu. Dr. Lin Liu is a professor of geography and geoscience at the University of Cincinnati. Dr. Liu received a bachelor degree in geography and a master degree in remote sensing from the Peking University, and a PhD in geography from the Ohio State University. His main research areas are geoscience and its applications. He's particularly interested in urban crime research in the US and China. He's regarded as a leading scholar on crime geography in the Chinese context. He has published scholarly articles on these topics in top journals, such as the International Journal of Geographic Information Science, Computers, Environment, and Urban Systems, and the Journal of Quantitative Criminology. He has published over 217 journal papers, book chapters, and edited volumes. Received multiple national level research grants and chaired over 15 international conferences. He served as department head and vice dean for international affairs of College of Arts and Sciences at the University of Cincinnati, and the president of the International Association of Chinese professionals in geoscience. It's a pleasure to welcome Professor Lin Liu.
Okay, thank you, Professor Huang. Thanks for the invitation. First of all, I want to say that although the topic is on crime, I have never been trained in criminology. I started the crime research as a hobby initially about 20 years ago, and then gradually sort of liked it. And now crime geography has been the major focus of my research. More than half of my publications are related to crime research. Today, so here's the outline of what I'm going to talk about today. So I will briefly talk about what is crime geography and the crime analysis, and then spend most of my time on the elements of crime analysis. And after that, I will briefly touch on some of the major challenges in crime research, the role and the contributions of big data, and some policy implications. And at the very end, I give a few concluding remarks. Crime geography aims to study the spatial temporal patterns and the processes of crime. By the way, there's no generally agreed definition of what crime geography is. I basically borrowed the definition of geography and made some modifications. And more specifically, I have this definition of a spatial analysis of crime. So the crime analysis I'm going to talk about today is sort of confined to the spatial analysis of crime. So it is related to geography, it is related to space and the place. So in my view, crime analysis consists of the following elements. So the detection, the explanation, and the prediction of crime patterns, development and the implementation of strategies for crime prevention and investigation, and then finally, evaluation of the effectiveness of the implementation. So first of all, I would like to talk about the types of crimes that have been studied most often in the literature. So first, I want to make this distinction between contact versus non-contact. So like street robbery would be a contact crime, burglary would be a contact crime, and cybercrime. So if your identity got stolen, then that's not non-contact. So fraud and cybercrime, which I have listed here, these are not are non-contact crime. Street crimes and some off-street crimes, they tend to be contact related. Then on top of that, we have drug crime, gang-related violence, kidnapping, terrorism, animal poaching, environmental crime. So those are some of the crime types that frequently appear in the literature. I have my own research have covered quite a few of them. I have not studied the gang violence. I have not talked about kidnapping or terrorism or animal poaching, and others have covered to various degrees. Now, before we talk about the crime analysis, I want to talk about the data, crime data itself. There are three main types of crime data. Calls for service. So every time you call 911, that is recorded in the database. And the second one is the crime database itself. So when the police department receives a call and send up an officer to investigate, if it is indeed a crime, then that would become part of the crime database. Arrestee database is derived from the court record. So the crime got solved and the offender got captured and sentenced, then the information about the offender would appear in the arrestee database. So these are the three databases that are most frequently used in crime research. Cost for service represents the demand for police. Crime database itself tells where what kind of crime appears where. And the arrestee database would tell you who committed the crime. So in terms of a call for service, so we have 911 calls in the US. In the UK, it will be 999, and then 112 across the Europe, and 110 in China. Now, in terms of the crime database, there is something called the Uniform Crime Reporting, or UCR. This is collected by FBI. This is a database that is voluntarily contributed by the local police agencies. So you can tell that if a local police department doesn't want to participate in reporting to the UCR, then you don't have the data for that particular police department. So this UCR database has two parts. Part one is the more serious. So it would have violent crime, homicide, rape, robbery, assault. And it also cover property crime, so burglary, motor vehicle theft, larceny, theft, arson, and so on and so forth. And then there's this part 2 database. This would be less serious. Now, what do we do in crime analysis? I made this chart. So in my view, it has 5 components or 5 elements. So first, you start from the detection of pattern. So do crimes distribute evenly or randomly in space or in time? Okay. So this would answer the what question. Once the patterns are detected, then the next step, the next logical step is to ask the question why and how. So what are the factors that are related or that contributed to the formation of the pattern? So this is where we need to use explanatory variables to explain the crime patterns. And the next element is prediction. So we know what has happened in the past, and we know what factors might be able to explain the crime. The next question is, could we predict what's going to happen in the future? So that's crime prediction. Now, once we have know all this, can we somehow intervene so that we can prevent future crimes from happening? That would be most ideal. In reality, it is not entirely possible. And then a step back option would be, could we do something to reduce future crime? So this is where you come up with different strategies with the hope of reducing crime. Now, did those implementations really work? We need to evaluate it. So this is the evaluation and assessment. Now, intervention could change the spatial and the temporal patterns of crime. So that leads us to the very beginning. So the patterns may have changed, and so this loop continues. So it's a live system. It has lots of feedback loops. And so that's why this kind of analysis will never stop. It will continue as long as the society exists. So now I'm going to look at each of the 5 elements, starting with pattern detection. Now, pattern detection techniques or methodologies usually are divided into these global and local categories. Global detection will basically say, yes, there is a pattern because it is not a random distribution, it is clustered. And the local will be able to tell you where exactly the high concentrations are. So in terms of global detection, we can use Moran's I, Getty's odd, the G index, or Geary's C index. This would help to figure out whether there is a clustering in the overall distribution. Likewise, we could use nearest neighbor analysis, Ripley's K function. This is not a comprehensive list. There are other approaches that could be used for global detection of crime pattern. On the local side, LISA, this is Luke Anselin's local indicators of a spatial association. So local plot, LISA plot will tell you the local patterns of crime. And of course, a very popular approach is the density calculation. So you divide crime counts by area and you get a density. And high density areas would be where high concentrations of crime are. Now, I made this distinction. Some scholars may not agree with me on this grouping, these 2 groupings, Like some would argue Moran's eye could be used as a local. Yeah, that is probably true. So I do want to add a disclaimer that some of the indices and the methods can be used for both global and local detections. So I want to start from the spatial side, spatial patterns. Crime distribution follows the 80-20 law, or this is what's called the power law, which basically says 80% of the crime are concentrated in 20% of the places. Okay. And actually this 80-20 law can be extended to the non-spatial context as well. So for example, 80% of the crimes are committed by 20% of the offenders. And we can extend it to the temporal dimension as well. 80% of the crimes are 80% of the crimes occur at only 20% of the time. The exact spatial pattern may vary by crime type. So for example, robberies tend to concentrate like in downtown or the neighboring areas. Burglary, on the other hand, tends to be more widespread. So here I have a map that shows both street robbery and burglary in Cincinnati. Street robbery is shown as a red dot in red dots. Burglary, on the other hand, are shown in blue dots. And it's fairly easy to see that the red dots tend to concentrate here. So this is downtown Cincinnati. And the blue dots, you see the blue dots everywhere. Wherever there are residential properties, you might be able to see residential burglaries. And if we separate these two types of crime and make individual maps for each of the two, and the left side, the one in green, would be street robbery. And the one on the right would be burglary. Again, you can see, you see concentration here versus burglary is more widespread. And you do see like regional differences. So for example, here, there's not much crime, not much burglary, and this happens to be the more affluent area of the city or rich places. So the central part and the western side have more burglaries. On the temporal side, the pattern between day and night can be different. Likewise, weekends and the weekdays and the weekends are different. There may be seasonal variations as well. In places where the 4 seasons are highly distinctive, such as Chicago, such as Cincinnati, you definitely see more crime during the summer month. In tropical areas where you don't get 4 clearly different seasons, that seasonal variation is not as obvious. So I do research in southern cities as well. They demonstrate much less seasonal variation as compared to Cincinnati. Holidays can impact the crime as well. So in the US, during Thanksgiving and the Christmas, burglaries and the robberies tend to increase actually, versus Chinese cities during the Chinese New Year, crime will drop significantly. So, so there are patterns that differ from one society to another society. These can be culture related or can be related to different stages of the development of a country. Likewise, crime vary by crime the pattern vary by crime type as well. Theft, for example, are usually associated with the concentration of people, therefore tends to occur during the day and early evening. Because after that, people are home, then you have less target. Robbery tends to concentrate in the evening. Aggravated assault tends to occur more in the late evening. And burglary, it's different because burglary happens either at night or during the day when people are away from home. And I have two charts here. Again, these are street robberies and burglaries in Cincinnati. So as you can see, robberies tend to concentrate in the evening hours. And the burglary is, you don't see clear, very clear peaks. Although you do see like here, and somewhere around here. I do want to sort of make a note that the exact time of a burglary is hard to obtain. Like when you wake up in the morning and you notice the house is being burglarized, but you don't know exactly at what hour that really happened. Likewise, when you return from home at 6 or 7 in the evening and you notice the home got burglarized, but the exact hour you may not know. So it could be anywhere from 8 when you left home for work, all the way up to like 5 or 6 right before you came home. And some research would combine the spatial and temporal aspects to detect the patterns. So there's something called hotspot matrix, in which would divide the spatial distribution of crime into 3 different categories, like random distribution or more uniformly distribution versus multiple clusters versus a single cluster. And on the temporal side, there's no clear pattern during the 24 hours of a day, versus here there's a clear peak, and then the rest of the hours are sort of more or less the same, versus a single peak. So you have 3 patterns on the spatial side, and you have 3 patterns on the temporal side. So 3 by 3, you could get 9 possible different combinations. And this is something that are empirically supported by some of the research of my own group. And another way to combine the temporal aspect and spatial aspect is this near repeat. The near repeat analysis would identify pairs of instances that are near in space and in time. A typical finding would be like one crime incident may lead to another crime within 200 meters in less than 2 weeks. And this usually is tested through something called a Knox test. Roughly speaking, 30% of all crimes belong to near repeat pairs. The second element would be crime explanation. This is where we have explanatory models to explain what factors may have an influence on the spatial and the temporal patterns of crime. The most common models are Poisson and the negative binomial models. these are different from the ordinary least squared model or OLS models because the counts of crime do not follow a normal distribution. They are skewly distributed because, again, of the 80-20 law. On top of that, we may use multi-level models. By the way, multi-level models can be Poisson or negative binomial models. However, a multi-level model would involve at least two different levels. Maybe one level is the street segment and the other level is the neighborhood. And with multi-level models, you can study moderating effects. And the third group of model would be structural equation that will be able to help us to assess direct and indirect relationship. Now, how do we select the variables used in the explanatory models? The selection of variables is typically driven by theories and the literature. I have here listed 4 popular theories in environmental criminology and in crime geography. One is social disorganization, the second is routine activity, and the third is rational choice, and the third, number 4 is crime pattern theory. The variables can be broadly divided into 2 categories. One is the social environment. This would consist of economic status, racial composition, population structure, housing, neighborhood stability, and so on and so forth. The sources of this kind of data, one is the census, and in between census, we typically rely on American Community Survey data. And the other main source is the internet. So geotagged social media data, cell phone data, GPS tracking data, Twitter, Facebook, and maybe other sources as well. In addition to the social environments, we have built environments, transportation network, land use, facilities that attract or generate crime, natural edges or transitional areas between zones, etc. These kind of data may come from remote sensing images, navigation based maps, which may have point of interest, LiDAR, street view. Again, street view is also part of navigation data sets. Night light data, again, this is a special type of remote sensing images. What do we need to pay attention to? If you have too few number of variables, then the models will not be stable. That is, if you add or drop a variable, the results of the model become different. That's what the instability of this is referring to. And from the model, well, we can use the p-value to check which of the explanatory variables makes a statistically significant contribution to the dependent variable, okay? And for the statistically significant variables, we can further look at the standardized coefficient. So whichever variable that has a higher coefficient tend to have more influence on the crime distribution. The third group of the third element of crime analysis is prediction. The underlying assumption of virtually all predictive models is that past trends are likely to be repeated in the future. Okay, I'm going to say this again. Past trends are assumed to repeat in the future. If that assumption is not true, then you cannot predict the future. So the fact that we could make some predictions to a certain degree indicates that this assumption has some validity. We often heard all kinds of predictions. Crime prediction is one, prediction of earthquakes, prediction of eruption of volcanoes. Those are predictive models. Now, what are the techniques or methods being used for crime prediction? Density mapping is one. Especially the mapping that considers a spatial temporal autocorrelation, which basically assumes that near events have a higher impact on the future. And then the other group of crime prediction models is machine learning related. I listed a few machine learning algorithms, but the list can be very long. Some of the machine learning algorithms are purely based on historical patterns. They don't need covariates. The covariates are the ones that could explain crime. So machine learning algorithms can predict the future crime without using explanatory variables. And we have demonstrated in our own research that if you add covariates, then the predictive power could be enhanced. There's a question that you need to ask all the time is that whatever model that you come up with, is the model generally applicable? So if I come up with a model using the data of Cincinnati, then could I apply the model to Chicago, for example? And prediction can be very challenging if you want to have very high resolution predictions. High resolution refers to spatial resolution and the temporal resolution. So spatial resolution, high resolution would be an intersection of two streets. And high temporal resolution, you can be like tomorrow at noon. So if I say, okay, can you tell me, would there be any crime tomorrow at noon at the intersection of Main and the Broad Street? Chances are I cannot tell you because high resolution predictions are challenging. If I'm forced to give you an answer, I probably say no, because the crime follows the 80-20 law, right? And how do we assess whether the predictions are accurate or not? You could do cell-by-cell correlation, but again, that may not help that much, again, because of the 80-20 law. So 80% of the places may not have any crime. So if you do a correlation, then you can easily get a correlation coefficient higher than 0.8. Is that good? May not be. And the people have come up with all kinds of indices to assess accuracy of prediction. So PAI and the PEI are two of them. However, one favors low resolution, the other one favors high resolution. So you can never develop a model that can maximize both of them. So indices for assessing accuracies of crime prediction models are still a topic of research. So now we know the past pattern and we know the explanation to a certain degree. And to a lesser degree, we may be able to predict what's going to happen in the future. The next logical question is there something we can do about crime reduction? So this is a main topic for policing. The standard model would be random policing. You take no intelligence. You assume no prior knowledge. And then you have community policing, that is, you send officers to local communities, develop a good relationship with the citizens in the community, and with the hope of reducing crime. Hotspot policing is closely related to crime geography. So that is, if we can detect the hotspots, could we send more resources to those spots? And there is a large body of literature on hotspot policing. Some would suggest hotspot policing is not effective. Others would say it is effective, but the effect may drop in time. And the third one is problem-oriented policing. And we tend to focus on hotspot policing because it is closely related to crime geography. Impact assessment, whether the implementation of a crime prevention strategies is successful. There are a bunch of questions that need to be asked. Is crime reduction in the treatment area or in the targeted area? Usually, yes. Would the crime be displaced to the neighboring areas? Sometimes it happens, sometimes it doesn't. Then, is there diffusion of crime reduction benefits to the neighboring areas? If the answer is yes, that is very desirable, and that would be a success. So how do you assess this? Well, you can run experiment in simulation, you can do natural experiment, or you can do randomized control test. And the methods, there are all kinds of methods. Location quotient-based methods. So we have two of them, weighted displacement quotients, spatial temporal weighted displacement quotients. And then we can run differences or DID regression. We can use propensity score matching and so on and so forth. We have done a number of studies along this line. So one of our studies studied the effectiveness of a surveillance camera. And we found the initial effect, that is right after the surveillance cameras are installed, crime are reduced. And however, that effect become less and less significant in time. And another study is we found removal of a bus stop would not have a significant impact on crime reduction. However, when you add a new bus stop, that would lead to an increase in crime. And that effect is statistically significant. We also look at the opening of casino. Jack Casino is a casino in downtown Cincinnati. And we found that it had a significant impact on the increase in property crime in the adjacent areas, but it had no significant impact on violent crime. Challenges. especially with the data-driven approaches like machine learning, exploratory data analysis. These research tend to be less connected with the literature and establish the theories. So therefore, sometimes you find that the results of these kind of a research are not widely applicable. And second challenge here is meta-analysis. There are many case studies. Some tend to contradicting with others. So is it possible to perform a meta-analysis to systematically generalize from the published studies? Are there any differences amongst different societies and the cultures? And the third challenging is on the methodological side. There's this what I call the spatial temporal mismatch problem, because here the dependent variable has very high spatial temporal resolutions, because for a crime, we know the location and we know the time. But the independent variables tend to have very low spatial resolutions. So census variable, the smallest area units would be census blocks, right? It's still fairly large compared to a point location of a crime. This problem is not unique for crime analysis. All public health related research, as long as they use point data, will run into this problem. So what is the solution? Well, typically we sacrifice the high spatial temporal resolutions of the crime data to match it with the census variables. So that's a very typical approach. But with the help of big data, we may be able to derive explanatory variables that have higher resolutions. So recently, there are more publications along this line. So what are the big data? I have a few listed here, like cell phone derived data, GPS tracking, taxi ridership, smart cars for buses and subways, tweets, especially geotagged tweets, online communication apps that may detect your location. So like WeChat is such social media platform that could generate a heat map, which shows the concentration of people in virtually real time. Like every 5 minutes, it can give an update. Nightlight satellite images is another source of data. Street view images. I think most of us must have seen some of the images. So every time you go to Google Map, and you should be able to access street view images. So at like various locations along streets, pictures are taken in 4 different directions. Those images tend to be rather densely located. SafeGraph is another such data. And here I have a few examples listed here. This is a satellite nightlight image of Cincinnati. They're from different sources. So here is the original aerial photography or satellite images, and here is the VIIRS. This is a US product. Logia 1-01 is a Chinese product which has a higher resolution. And our analysis has demonstrated that night lights can help explain crime. Geotagged tweets, one of my former PhD students, who is a professor in Toledo right now, his dissertation research is on the topic of using geotagged tweets to explain crime. So here is spatial distribution of geotagged tweets in Cincinnati, and here is geocoded crime in Cincinnati. You see some sort of connection between the two, right? And so the role of big data. The first is we could derive new explanatory variables with high spatial and temporal resolutions. So that is new. And this can be a viable solution to the resolution mismatch problem, which I just referred to, explained the significance. New dimensions to existing theories in the literature. So we were able to review the impact of mobility. Usually you tend to have this spatial neighborhood averaging effect. Originally pointed out by Professor Maple Kwong. And we may also be able to review some nonlinear relationship. For example, the impact of lighting robbery and car vandalism, and the impact of housing price on burglary. These tend to have nonlinear relationship. I will use another 5 minutes to talk about the policy implication and then give concluding remarks. So policy implications. First, we have challenges. I mean, I think that these challenges can be universal. The first one is those used in practice are rather mature. They may not necessarily need new technology. On the professional side, they tend to be natural resistance to new changes. And I think professors have that issue as well, especially senior professors like myself. And the second challenging is those written in scientific papers may not be very useful. Because they are too far ahead, which cannot be implemented in reality. And so what can be used for practice? I listed two of them, two categories. One is the spatial temporal patterns that could be used for targeted policing, the hotspot policing that I mentioned earlier. And also variables that can be used for intervention. So we have these explanatory models, and we know crime can be associated with some factors. And if those factors can be intervened, then we may be able to do something about it. So again, a little bit of elaboration on these two approaches. So targeted crime prevention, we can do hotspot policing, and we can predict future hotspots and allocate policing resources accordingly. And then the factors that could be intervened, microenvironment. So if we notice graffiti on the walls or along the sidewalk, then we can have them covered. And hardening of targets. So if burglary is a main, it's prevalent, then we could put iron bars on the window. Surveillance of suspects. So if you know who the suspects are, then you might be able to do something. these are the possible implications. So what can we do? I put urban planning here specifically because there is a subfield in criminology, in environmental criminology, which is called the crime prevention through environmental design, CPTED. If you can find factors that can be associated with crime, then in the initial safety planning, you could do something like proper lighting on streets and the back alley, proper height of a bush along the street. You don't want the bushes being too high because that will reduce the visibility, and the less visibility can encourage more crime. Positioning of bus stops, security of the wholesale locations, security of entertainment districts. Of course, there are ethical issues in crime analysis. First, crime data itself may not be publicly available. Now here in the US, crime data itself is available in the public domain, but that may not be the case elsewhere. In some societies, crime data can be highly confidential. But also the data that we use to explain crime could be sensitive. For example, data collected without explicit consent of the user. So data collected through the smartphones, a lot of them may not have the explicit consent of the users. Privacy issue. So if you use a video surveillance, there could be privacy issues. It could be confidentiality issue. I mentioned the crime data itself. Recently, I have seen more ethical concerns with machine learning and geographical profiling. They may reinforce certain behavior. Finally, some concluding remarks. So as you can see, crime geography and the crime analysis involves basic research, applied research, and application. It is inherently interdisciplinary, and we can see criminology, geography / GIS, computer science, social sciences being related to it. And also this, the spatial resolution mismatch problem, it is why it may be widely applicable, and policy implications are always important for crime research, and because the ultimate goal is that what can you do to reduce and prevent the crime, right? So most of the materials that I have included in this presentation come up from these 2 review papers I published. And there are additional papers. I think there are more than 100 crime-related papers that are available on Google Scholar. So that's all. Thank you.
I think Professor Liu gave a great talk about the comprehensive examination of crime geography and crime analysis. So now we are open to the questions. So I think the first question I have, okay, Jeff.
I'm muted again. Go ahead, ask your question first.
Oh, okay. So I think you mentioned like the contradictor and for the meta-analysis have like contradicting each other. Could you give more details about these contradicting results about the crime geography and
Okay, a good example of that is the hotspot policing.
Mhm.
Whether hotspot policing is effective or not. And they are starting from the 80s. They will report on this experiment in Kansas City. And the conclusion is hotspot policing is not effective. And the Rand Corporation also had some follow-up studies on that. And it's not conclusive. And more recently, the Philadelphia Police Department worked with Temple University, and that study actually showed some effectiveness of hotspot policing. I have done some research as well, and our research result indicate hotspot policing can be effective. So now, what's the reason behind these inconsistencies?
Mhm.
The design of the experiment,
Mm.
what is controlled, what is not controlled. So some findings may be a byproduct of other hidden variables.
Mm.
So you do have to look at the details of the of design and implementation. Design is one issue. Design is important, but implementation is also important. In one of the studies, they noticed that if the targeted policing is performed by veterans, the police who have worked in the department for a long time, then it's not effective. If it is performed by the junior officers who don't have much experience, it is effective.
Oh, okay.
So there are just a lot of loose ends
I
in the design and execution of the prevention strategies that could affect the results.
Okay. Okay. Thank you,
You're welcome.
Jeff.
Oh, let me. Oh, hang on. Oh, I'm unmuted. Okay, sorry. I thought I was muted. I found your mention of the temperature effects quite fascinating. And so you were saying that in some places with climate where it doesn't get very cold, that there's not a dip in the winter, and I guess I'm a little surprised by that because I would have still expected daylight to play a role, the amount of daylight. Can you possibly comment on why the amount of daylight doesn't play a role?
Well, I don't think our I think we're on the same page. When I say southern cities, I'm talking about Northern Hemisphere. So of course, southern cities are less affected by their daylight, are less affected by during the 4 seasons in a year. I realize there's some effect on during the summer, the daylight will be longer, and during the winter, the daylight will be slightly less. But it's that impact is less pronounced in low latitude area. It's more pronounced in high latitude areas. So in high latitude area, coupled with the temperature, so it's sort of a double whammy on the crime. And I have empirical data to support that. So like in places like Chicago and Cincinnati, summer, the summer crime is far more than winter crime. In places when the latitude is in the lower 20s, that difference between summer and the winter is far less.
Okay. Yeah, I know in Chicago we have a spike in January, which I think most people attribute to New Year's Day. But yeah, usually it's much more crime in the summer than winter, with the big exception of and by crime in this case, it's murders, not so much general crime, but we get a big murder spike in January, and then it falls back down February, and then comes back up in the spring and summer. So it's a very interesting thing, and I was just wondering if daylight played any role in that. Do most of these things take place at night, during the day, late evening? But I find this work that you're doing absolutely fascinating. So thank you very much for presenting it here today.
You're welcome. Thanks. And also the other, I want to add, for kids, especially high school students, like they have like a long summer break, like sometimes 3 months, 2
Sure.
to 3 months, and the winter break is much shorter. So
Mm.
that has a role as well.
Interesting.
Okay, our is exactly our time is already past 5 minutes. So thank you so much, Professor Liu, give us a wonderful talk. So usually we give the applause to the speakers at the end. Thank you so much.
Okay, you're welcome. Thanks for the invitation. And also thank you all for participating.
Yeah, thank all the audience participating.